Hello everyone. In this video, to see the another method in architecture level approach, that is parallel processing approach. The another name for parallel processing approach is hardware replication. So here in that previous video we discussed about the pipelining approach, that is one kind of architecture level approach for the low power design. So here we have to utilize the parallelism or hardware replication for the low power design method by reduction of area as well as the power dissipation. So in this parallel processing approach, here we have to see the diagram that is structure for the parallel processing approach. It consists of n identical processing elements. Here consider the n identical processing element, so each implementing with the logic function f of input, and the input is given to the input register, and the each and every input, that is n number of input, is given to the input register with the clock 1, clock 2 up to clock n. Here in that pipelining, the f clock is given to the corresponding input corresponding the register of all register of the corresponding structure, but here the clock frequency is divided by the n number of logic blocks. So the clock is denoted as f clock divided by n. So this is operated with low frequency. So the output of each logic function is connected with the multiplexer. So then the output of the multiplexer is connected to the corresponding output. So multiplexer is connected to the register. The output is taken from the register. Here the f clock is given to the output register. So we have to calculate. So we are calculating the power dissipation for the n number of blocks as well as the output block. So the input vectors are routed to all register of the n processing blocks. That means here the clock signal had a gated clock signal, each with a clock period of n into t clock, that is used to load the each register in every n clock signal cycles. So here we have to the input of each logic function is connected through the n number of register. So the clock is given to the corresponding register. The total clock period is calculated with n into t clock. So here that means the input register is coded by t clock. So n number of consecutive input vectors is loaded in the different input register. So here the clock is will be divided by the n number of n number. So it is operated with a low frequency, and the output, that is the output of the n processing blocks are multiplexed and sent to the output register, but the output register is operate with the clock frequency f clock, so that is denoted as the f clock bar. So it gives the same throughput rate for the corresponding logic. So here when you are using, the frequency is less, that means the f clock by n is given to the each input register, so that the value of the VDD, that means the VDD it will be reduced, that is denoted as VDD new. And here, so the new power supply is given to the corresponding parallel processing approach, is similar to the pipelining. So here in that parallel processing approach, here n number of block is connected in parallelly. In that pipelining approach, n number of logic gates is connected in a series manner. So like a pipe arrangements manner. So one pipe output is connected to the input of the next pipe. Similarly, for n number of pipes is connected in a series. So here in that parallel processing, it will be connected in a parallel manner. So that compared to the pipelining, the complexity of the designers, it is very easier. Here the same structure, like a single stage architecture for the pipelining, that will be is repeated n times. So it is also called as hardware replication. So here the first logic 1 function is the same structure is repeated n times. So this structure is called as hardware replication. now we have to find the power calculation, power reduction achievable with the help of the calculation of the power in to the corresponding n number of blocks as well as the output. So the total dynamic power dissipation of the parallel structure is bound the sum of power dissipated by the input register and the logic blocks operating by the clock frequency FLN. So here we have to neglect the power dissipation for the multiplexer. Only you have to consider the number of logic blocks, the power dissipation by the logic blocks as well as the register. So the parallel power dissipation for the parallel is equal to n into C total into VDD nu square plus into F clock by n. Here the individual logic block, the corresponding register, the clock frequency is given by F clock divided by n. So here we have a n number of blocks, so we are taking n, and we have to neglect the power dissipation for the multiplexer. So in output side we are taking only the power dissipation for the register. So the corresponding capacitance C register into the supply voltage VDD nu square into the it is operated in F clock. So you have to denote F clock. So this is a simplified expression for the power reduction achievable by the parallel processing approach. So that is equal to 1 plus C register divided by C total into VDD squared nu into F clock. So here, so when you are getting the ratio between the parallel approaching as well as with the reference power dissipation, so you already know that the power dissipation for reference, that is P dynamic power dissipation is equal to C total VDD squared into F clock. So by getting the ratio, so that is equal to VDD nu square divided by VDD squared into 1 plus C register divided by C total. So the next one, the lower bound of switching power reduction reliable with architecture driven voltage scaling is found assuming zero threshold voltage. That means the power dissipation of parallel with the corresponding reference power dissipation should be greater than or equal to 1 by n squared, means we have to achieve the zero threshold voltages. So here in this comparing that pipelining as well as the parallel processing approach, so both the approaches are the increased area as well as increased latency. That means in that parallel processing approach, the n number of logic block is connected in series. In a parallel in pipelining, in parallel processing it will be connected in a parallel manner. So here we are analyzing the timing diagram for the corresponding parallel processing. Here this is a timing diagram for the parallel processing. Here when you are using the clock signal, so this is a first clock 1, here clock 2, this is clock 2, 3 up to clock n. So here the input is given to the input 1, input 2, input n for the corresponding n number of logic block. So when clock 1, the first input is loaded to the first logic function. In clock 2, the second input is loaded to the corresponding second logic function. So similar manner, for the nth input is loaded to the that is input n is loaded to the corresponding nth logic block for the clock input n. But we are getting output after completion of nth clock cycle. We can get the output for the first input 1. So this is similar to the pipelining structure. So the latency of the corresponding parallel processing is equal to, that is n number of clock cycles. So that is one kind of disadvantage in both pipelining as well as the parallel processing. But the power reduction as well as the area, area is somewhat increased, and power reduction is reduced when you are using pipelining as well as the parallel processing. So with the help of reducing the power dissipation, it maintaining the throughput, high throughput. So So where we have to utilize, where we are not able to utilize the pipelining method, so at that place we have to utilize the parallel processing, because in both the method having the difficulties is faces, that means the latency of the corresponding parallel processing as well as the pipelining is n clock cycle. So where the latency is not important, at the place we have to utilize any one kind of method for the architectural level approach, like a pipelining or parallel processing approach. Here where the parallel pipelining is not utilized, at the place we have to utilize the parallel processing approach. So compared in both the method, we have getting the area is somewhat increased and the latency is n clock cycles. So here the parallel processing approach is also called as hardware replication, because in that method we have to utilize same kind of hardware is repeated n number of times. So it is called as a hardware replication. Thank you.